Hi students, I am Vishnumurthy, lecturer in physics, Pandit Degree College, Gopalapuram. Previous class we discussed electric field intensity and potential. Today we discuss Gauss law. We discuss Gauss law. Gauss law connection between flux of pi of an electric field through any closed surface, hypothetical surface or Gauss surface, the net charge Q enclosed by the surface. The net charge Q enclosed by the surface. Gauss connection between flux pi electric field through any closed surface or Gauss surface the total charge Q enclosed by the surface. Gauss connection between flux pi electric field through any closed surface or Gauss surface, the total charge Q enclosed by the surface. What is flux? The electric flux through a surface placed inside the electric field represents the total number of electric lines of force crossing the surface. Direction in a normal to the surface. What is electric flux? Electric flux denoted by pi. The electric flux through a surface placed inside electric field represents the total number of electric lines of force crossing the surface in a direction normal to the surface. This is electric flux. Denoted by pi. The electric flux through a surface placed inside the electric field represents the total number of electric lines of a force crossing the surface in a direction normal to the surface. A simple example: consider irregular shape of surface. Electric line passing through the surface. Electric field E bar in a direction normal to the surface. I'm taking surface ds, small area, in normal to the surface. Let surface area ds, electric field like this, E bar, surface area like this. E and ds get some angle theta. This is electric flux. The electric flux is a scalar product. This is a scalar product. E and ds is defined as the electric flux pi for the surface. This is electric flux. Electric flux denoted pi suffix e equal to product E dot ds, the surface area taken, surface integral E dot ds. E and ds is a scalar product where theta is the angle between E and ds, where E is electric field intensity, or electric lines. ds is surface area, a small area. Okay. E dot ds, the electric flux E dot ds is a scalar product. E dot ds is a scalar product is given by E dot ds equal to E ds cos theta. Now electric flux pi equal to surface integral E dot ds. Now this equation substitute surface integral E ds cos theta. E cos theta surface integral ds, where surface integral ds equal to a. Surface integral ds equal to nothing but a. A is area of surface. Electric flux pi equal to E cos theta into A. This is flux mathematical equation. Now Gauss statement. We discussed Gauss statement and proof. Okay, Gauss statement. Gauss states that total normal flux. Gauss states that the total normal flux pi over a closed surface of an electric field 1 by epsilon naught times the total charge Q enclosed within the surface. This is Gauss statement. What is this? Gauss states that the total normal flux pi over a closed surface of an electric field 1 by epsilon naught times the total charge q enclosed within the surface. Mathematically, flux phi E equal to surface integral E dot ds equal to surface integral E ds cos theta equal to q by epsilon naught. Q by epsilon naught. This is Gauss statement. This is Gauss statement. Now, prove. Gauss statement. Two cases are there. First case, when the charge is within the surface. When the charge within the surface. Next case, when the charge is without the surface. Two cases are there. First case, when the charge is within the surface. When the second case, when the charge is without the surface. Now taken surface area. First case will be this. We discuss first one. When the charge within the surface. Let's take a surface area. Taken a charge, positive charge, at point O, electric field E at point, surface area on the point P, distance R from O, solid angle d omega, surface to normal ds. Some angle is there, is angle theta. Let a charge plus q be placed. Let a charge plus q be placed at O within a closed surface of irregular shape. Consider a point P. Consider point P on the surface at distance r from O. Now we take a small area. ds around P. Small surface area ds around P. The electric flux d pi outwards through the area ds is given by d pi E equal to E ds cos theta. This is equation 1. Let's consider surface area, irregular shape, like a charge plus q be placed at point O within a irregular shape. Consider a point P on the surface. Now we take small area ds around the P, around the surface area P. The electric flux d pi, electric flux, the electric flux d pi outwards the ds through the area ds is given by the electric flux d pi equal to E ds cos theta. This is equation number 1 is electric flux. Now from Coulomb's law, the electric intensity E at a point P, distance r from a point charge q, is given by electric intensity E equal to 1 by 4 pi epsilon naught into q by r square. This is electric intensity, equation number 2. From given equation, electric flux d pi equal to E ds cos theta. This is equation number 1. Now equation number 1 and equation number 2, from 1 and 2, electric intensity E equal to 1 by 4 pi epsilon q by r square. This is equation, substitute E equal to 1 by 4 pi epsilon naught q by r square, substitute equation 1. In equation 1, d pi equal to E value 1 by 4 pi epsilon naught into q by r square to ds cos theta, where 1 by 4 pi epsilon naught into q ds cos theta by r square. This is solid angle equation. ds cos theta by r square nothing but solid angle d omega. Now solid angle, substitute above equation, d pi equal to 1 by 4 pi epsilon naught into q into d omega. The total flux surface integral d pi equal to surface integral 1 by 4 pi epsilon naught into q into d omega, where derivative of flux and with respect to integral and derivation cancel. Electric flux pi equal to q by 4 pi epsilon naught surface integral d omega. Surface integral d omega nothing but 4 pi. This value of solid angle equal to 4 pi. Electric flux pi equal to q by 4 pi epsilon naught into 4 pi, where 4 pi cancel. Electric flux pi equal to q by epsilon naught. This is a Gauss statement. Gauss law proof. The total normal flux over a closed surface of an electric field 1 by epsilon naught times the total charge q enclosed by the within the surface, enclosed within the surface. This is Gauss establishes statement. Gauss statement is true. Gauss law is true, equal to q by epsilon naught, where within the surface, within the surface, the total normal flux, over a closed surface is equal to 1 by epsilon naught times the total charge q enclosed within the surface. Gauss law is defined. This is Gauss law. Now discuss second case. When the charge without the surface, now taking a closed and closed surface, cone shape. Now like a point, positive charge outside point O. We are situated at point O outside the closed surface. Now cone of solid angle d omega, with separation points P, Q, R, S. Let area ds1, second area ds2, and third area ds3, last area ds4. Now electric field passing through a closed surface, enclosed surface, the charge inside the flux, inside the surface, is leaving the surface. Third one, inside the surface. Fourth one, leaving the surface. This is outside the surface charge q. Now cone of solid angle, now cone of solid angle d omega from O. See, d omega from O. Touch the surface, areas ds1 and ds2 and ds3 and ds4, at points P, Q, R, S respectively. The electric field inside the surface charge taken negative, leaving the surface positive, inside the surface negative, leaving the surface positive, The electric flux at P through area ds1 equal to area ds1 equal to entering the surface denoted negative q by 4 pi epsilon naught into solid angle d omega. Solid angle d omega. Next one, the electric flux at point q through area ds2 is leaving the surface ds2 equal to leaving the surface you at positive plus q 4 pi epsilon naught into d omega. Similarly, ds3 equal to minus q by 4 pi epsilon into d omega. ds4 equal to plus q by 4 pi epsilon naught into d omega. Similarly, ds3 equal to minus q by 4 pi epsilon naught into d omega, and ds4 equal to plus q by 4 pi epsilon naught into d omega. Equation number 1, equation number 2, number 3 and equation number 4. The total electric flux plus pi equal to ds1 plus ds2 plus ds3 plus ds4 plus pi equal to minus q by 4 pi epsilon naught into d omega plus d plus q by 4 pi epsilon naught into d omega minus q by 4 pi epsilon naught into d omega. Next, plus q by 4 pi epsilon naught into d omega. Negative charge, positive charge, negative, positive. Then will be electric flux, total flux pi equal to 0. Total flux pi equal to 0. This case, the charge without the surface. This is electric flux. Now, within the surface, what is within the surface? Within the surface, electric flux pi equal to q by epsilon naught. Charge plus q charge within the surface. This is Gauss law. Gauss law as proved. Now, Gauss law differential form of Gauss law. Differential form of Gauss law. According to Gauss law, surface integral E dot ds equal to q by epsilon naught. The equation epsilon naught into surface integral E dot ds equal to q. Equation number 1. Then q is a charge. Let a charge q be distributed uniformly over a volume. Volume V and rho be the density. Rho be the density. Let charge Q equal to volume integral to rho into dV. This is equation number 2. Equation number 2. Now, from equation 1, epsilon naught surface integral E dot ds equal to volume integral rho into dV. This is equation number 3. Now, we use divergence theorem. Now, we use divergence theorem. Now, we use divergence theorem. Surface integral to divergence theorem convert surface integral to volume integral. Volume integral, or simply surface integral to volume integral. Okay. Now, first equation, surface integral E dot ds is converted into volume integral divergence E into dV. This is equation number 3. Equation number 3. Okay. Equation number 4. Now, equation number 3 and 4. Equation number 3 and 4. Equation number 3, divergence E dV equal to equation number 3, volume integral rho dV. Volume integral rho dV. Therefore, this side, left hand side also volume integral, right hand side also volume integral. Divergence E equal to rho. Divergence E equal to rho. Simply we write del dot E equal to rho. Now, epsilon naught is there. Epsilon naught. Now, del dot E equal to rho by epsilon naught. This is Gauss differential form. We lecture del dot E equal to rho by epsilon naught and integral form flux phi equal to q by epsilon naught. This is Gauss statement. Thank you. Thank you, listening.